So, from what I gathered, we are today talking about a very important CPU in the computer history, 6502. So, Mr. Yasmin, take it away.
So you basically broke my idea of introduction because I was intending to ask you what is the similarity between Apple II, Apple IIe, Apple I, Atari, BBC Micro,
Atari 400, 800, 600,
Commodore PET, Commodore VIC, Commodore 64, Commodore
Nintendo NES,
28, Orao, Oric, TurboGrafx, Nintendo Entertainment System, and so on and so on.
And the correct answer is the 6502 processor.
To be completely precise, not the exactly 6502, but 6502 and some of the sub-variants of the 6502.
Okay.
Because we need to be precise. But my today's topic is not only the processor. The processor itself is a legendary thing.
It is.
It is so legendary that...
plus billion.
No, I'm going to go with this thing. Nobody knows how many processors have been built. Nobody knows how many processors have been sold. And nobody actually knows how many processors are being manufactured today because it has been in public domain. Almost all of the producers of anything have included it into their own designs. Mm-hmm. And the third thing is that... since there is no patent, there is no actually a way to measure how many processors are on the market right now. The number is in the billions.
I've read an article which states more than 6 billion.
Yes, so the number is in the billions. 6502 was part of almost all the keyboards on the market. Mm-hmm. It was part of the most...
Printers, scanners,
traffic lights, any sensors out there. So basically they're
I actually found a source that says it's heavily used in industrial automation to run the machines.
Yes.
Well.
Because
good.
Let's do a quick rundown on what 6502 is. But as I said, I'm not only interested in this processor. It's a legendary processor, but I'm also interested in this being a part of fundamentals that you need to have and use when you are doing computer science.
Oh, from an educational standpoint.
Yes, so because my main thing that is interesting in for the in 6502 is that this is one of those things that people, and by people I mean students today, don't understand why we have it. Mm-hmm. Why are we still teaching it? Because it is supposed to be 40 something
75.
Now it's coming to 50 years old processor.
It was 75.
Yes, so it's basically it is going to be in 2 years. It's going to be 50 years old, and it is still being produced. At the same time, Intel hasn't been producing any of the processors that they made basically two generations ago.
There are some older ones that they are producing, but that's an exception to the rule. The rule is there.
Yes, the rule is there. So. Almost none of the older processors are being produced right now, except for the Z80
and Motorola's
and the 602s. Mm-hmm. So, what makes the first generation of the processors so useful on today's market? This is the first thing, and why are they useful in the education market?
Can I try to start without actually knowing?
Yes,
I didn't read about this.
Yes.
I have a sneaking suspicion that I might know parts of the answers to the question. Which and you can freely correct me if I'm wrong, of course. We're talking about the CPU that was designed in 1975. Okay.
So basically, probably in 74, because in 75 it was on the market.
Yes, correct. Okay, but as you said, 50 years ago. The people of that age, I remember the articles and magazines that they were reading. We had a discussion about that last year. They were, in terms of the education and in terms of technical level, the people who were in this industry were millions of miles away ahead of most of the people today, which meant that they, given the current constraints of technology, created a CPU that was good out of the box, which works perfectly, which has been debugged to eternity.
And it was cheap.
It was cheap. And at that point in time, if I remember correctly, because I read about this some 20 years ago or so, it was something like 4 times faster than Z80.
Yes, because it was an actual RISC processor that was... Okay, but
there are still debates about that, I
yes,
think.
but it was the time when almost everything that we take for granted about processor right now was being debated and designed, because they weren't explicitly trying to design a RISC or a CISC. They were designing a processor.
For a purpose.
Yes, so in the 70s, we are now taking for granted that we know what a CISC is or what a RISC is. But back then, basically they were moving the boundaries as they moved along.
Oh, yes.
So the names for the interrupts, the names for the different things, the different flags, different parts of the processor were being made up as they moved along. So this is the one of the things that defines the IT in the 70s, because
it still does today.
Yes, but back then you more or less could hold almost all of the body of knowledge about the processing inside your head. Mm-hmm. You didn't need a huge team to be able to produce end result or end product. You could buy a processor on the market for cheap, develop something around it by using simple and cheap parts from the market. Mm-hmm. You could do it by yourself, mm-hmm. because you could both design the software and design the hardware. So you were able to be using the assembly language and the harder part, the harder design by yourself. Mm-hmm. And this is something that actually defined the way that IT was, I would say, creating a new generation of IT guys back then.
2 things. First thing, if again, I haven't read about this in decades, but literally, I do remember some snippets of data. I remember that in one of the articles that I read when I was, let's say, back in college, I think, about 6502, it said that the team of engineers who created 6502 were something like 15 people. That's impossible today.
Yes.
That's first thing. And the second thing that I distinctly remember was you mentioned the pricing. I remember reading in a scientific paper, it was some kind of an article somewhere, that the price of this was something like $25 to Intel's or Motorola's 200.
I think that the difference was even greater.
I think these were the numbers that I saw. I can actually look it up.
Yes, okay.
It was incredibly, enormously cheaper.
But I don't know the actual numbers because I was trying to find them, but I wasn't able to. But to be honest, I wasn't looking too much. But the thing that I know was that
I was correct. 25 to 200.
Okay,
roughly.
Can you just do the calculation and say how much is $25 in today's money?
I'm going to try to find that while we talk.
Okay. Anyways, I don't care about the actual amount. What I'm pretty interested in is how it related to TTL chips back in the day. Because in
$140.
So $140. This is a price of, let's say, Raspberry Pi today.
Yeah.
So this is something affordable to a person who is trying to develop something.
Yeah.
And the comparable price for the processor itself was comparable to other logical gates and everything else, the multiplexers, demultiplexers, and so on, back in the day. So if you wanted to develop something, this wasn't an expensive part. Today you cannot go to the market, buy a 13900 Intel, and then develop something about it. There is no way for you to do this.
Yeah.
You need a motherboard. Motherboard has to be developed by somebody else. Then
memory.
Basically,
OS.
there is no way for you to create anything on the 16-layer motherboard design. So you need either a specialized team or you need to buy something from the market, and you are going to end up with a normal PC. And back then, you could buy a handful of chips and create your own design.
Can I annoy you a little bit, at least in this episode, just for fun? What is the most favorite, let's say, the most famous bit of trivia related to 6502?
That it had an unknown instruction that they had to put in because everybody was using it?
I'm talking about human trivia, not technical one. many years later.
Yes.
A cartoon and a robot.
The Bender.
Yes.
The Bender one, because in Futurama, Bender is supposed to be running on 602.
Correct.
But in the multiprocessor system.
Yes. This would have been interesting back in the day.
But one could argue that today we are running in an extremely multiprocessor system as it is.
Okay.
Because your mobile phone is basically, 20 processors at the same time?
We're probably not too far off, actually, yes.
Yes, because in the real life, as you know, both of you are lecturers on something. I'm currently doing the computer architecture, and I'm doing 6502 assembly. I wouldn't call it a deep dive, but let's say introduction to 6502 assembly for the students. And basically, when we take a look at what 6502 defined in the assembly language and how it was defined, it stands today. Everything that they did is much more complex today, but everything they did is more or less defined in the same way. The way interrupts work, the way memory handling works, the way, single pipeline and no pipeline at all, basically, but single instruction execution, how it works. Everything is more or less as if you wanted to design a computer for the education. And what I don't understand, and I must say that I don't understand it for the last 20 years or so, is why, when we were doing the formal education back in the university, why did we have to learn on a simulated computer that was something else other than 6502?
Yeah, that's actually a question that's been bothering me as well for many years, because we had two college classes where we were doing assembly language. One of them was basically, from that standpoint, useless.
Yes.
And the second one was excellent for Motorola's. But the first one, which was about Z80 and the virtual non-existent Schmier computer, that's practically unusable, even back in the day.
I understand when back in the day Minix was a thing, because they needed something to be able to learn on, because the Unix as it was copyrighted, and it wasn't educationally available. You had to buy a license for it.
Yes.
And I understand this part, but from the hardware standpoint, in the 90s, 602 was completely okay to
learn the basics of computer science. Yes.
But not only
even
the basics,
more,
because right now, if you take a look at 602.org or any other website that is Visual 602 or something else, you are going to see that there is an enormous amount of resources available.
The following of that is basically cult status.
Yes, and the other thing is that you can actually get 602 assembly programs written today. People are actually writing for the process
still
today.
used product.
Yes, so I don't understand why people seem to avoid it so much, thinking this is an old processor. It is an old processor, but it is a well-aged processor.
Yes, to your point. Why are we teaching this class from the perspective of first 6502 and then ARM, and why not start with ARM? Please explain that to me. I have IQ 60.
First and foremost, I'm not teaching 602.
Okay.
I'm trying to explain to people how assembly language works, but I want to be able to explain not the particular assembly language. I want to be able to explain how different parts of the computer work. If I want to do this, I need a simple as possible, but working solution. I know that 602 is a working solution, and I want it to be as simple as possible, but not too simple. So I'm trying to avoid introducing additional variables like multi-threading, multiprocessing, and everything else.
100 registers.
The dozens of registers, let's call it dozens, that ARM provides. I'm trying to avoid hundreds of instructions. I'm trying to avoid introducing floating point arithmetics where there shouldn't be any floating point arithmetics right now, because the students, as they are when they come here, are not completely sure with integer arithmetic. So if I try to teach them floating point, it is just going to make it much more complicated to understand what I'm talking about. So I need to start somewhere. 6502 is as close to the silicon as you can go, but at the same time, it works. So I don't want to use something artificial. I want to have something that is and was running back then, something that defined the market for the small computers, because it
Home
did.
computers, yes.
So because
Personal.
small computers, personal computers, because back then, when you wanted to buy a computer, you could either buy an enterprise one, so basically extremely expensive timeshare or extremely expensive computer for yourself, or you could make yourself one, or you could buy one that was made by somebody, and those computers were cheap. I think the only computer that was close when it comes to the price was the Spectrum. So Z80 based generation of computers.
I agree.
Because to be completely honest, Z80 is an amazing computer by itself. Z80 is an amazing processor.
It is.
And I think that Z80 is even better than 6502 for a couple of reasons. But 6502 is much better when you need to teach somebody about...
For educational purposes.
education purposes, we need to teach somebody the basics. Because to be completely straightforward, I'm not trying to teach them assembly. I'm trying to teach them
principle.
how the computer works, and I need the assembly for them to be able to show me that they understand the principles.
So, as the Latin people would say, ab ovo usque ad mala, or from eggs to apples.
Yes, this is the one thing. And the other thing is that in order to be able to explain to me how addition works, you need to know at least how to say it in the mathematical language. So I need to
And
explain
in
the
digital
plus and
electronics partially as well.
Yes, but I'm not interested in electronics right now. Okay, 602 is amazing in this part, even because it is able to run basically on anything that is logically capable or capable of producing a logical signal, computer logic signal. So any signal level is okay with 602. The first generation, it was probably out of need, not out of what they wanted to do. They had to do it because they didn't know where it is going to be run at. And there is a lot of tweaks that have made 602s popular today, because the original series was running at 1 megahertz. Today, I think that one of the generations is running at 42 or 45 megahertz. So they have come a long way since then.
Okay.
They have created something that is basically free. If you want to produce 602 today, it is such a small component. It has so small footprint that you can create it for basically the amount of money it would take to just run the machines. The chip itself has no price. So it is cheap. The background is available. A lot of assembly is available.
A lot of documentation.
A lot of documentation is available, and a lot of solutions are available. I think I could argue with anybody that there is, given the amount of things that can be done on 602, that the amount of different solutions already available in the market is bigger than for some of the well-known languages today.
I agree. Okay. Actually, I asked your favorite AI friend today.
Yes.
Something. Your ChatGPT friendly. I asked him, why is 6502 still important today? So cost effectiveness, we discussed that. Reliability. It wouldn't be in use for 50 years if it wasn't reliable. Familiarity, a lot of people know how to program it. That's good. Then we get to some really important stuff like power efficiency. It doesn't consume a lot of power. It's an 8-bit CPU that consumes almost nothing. And the last but not least, which is partially your reason why you like it, which is nostalgia.
But I wouldn't be nostalgic, because if I were, I would go with Z80. I was always a Spectrum guy. I must say that
I was an Amstrad guy.
Yes, but I was a Spectrum guy. So I had a ZX and I had what was it?
128?
Z81.
Okay.
So, ZX was Z80 based. And I was a Spectrum guy. I wasn't used to thinking in the way that Commodore 64, which was the main opponent to the market, the way the programs were structured and the way the hardware was structured. Because the hardware in the Spectrum and hardware in the Commodore were completely separate things.
Yeah.
Commodore had its own set of dedicated chips for audio and video and so on. So I'm more of a Z80 guy.
Okay.
If I need to choose a side, but 6502 is such a simple thing to explain. It's
To you and me.
to anybody, because if I try to explain Z80, it has this small amount of things that makes it better, but makes it harder to explain when somebody needs to see how a processor looks like inside for the first time.
Well, it's going to be much worse if you ever had to teach something like Intel assembly language and instructions, because there are thousands of them.
There is something like
4,000 something.
Yes.
Yeah.
So, but we
Nothing
will go
against that. It's just a fact.
But I think that the problem becomes big when you when you see that basically you need to have a guide with you all the time, because you are unable to remember which instruction you want to use.
What do you think? What's the primary reason why, let's say, 6502 has such a basically small amount of instructions versus the Intels of today? What's the primary reason?
First, didn't need them. They
absolutely agree with you.
They didn't need them because they didn't know what to expect. A lot of the instructions in the Intel world or the CISC world came from...
Intel is not CISC.
No, so sorry. Okay, Intel is what?
Both at the same time.
Yes, but they are CISC. They are complex instructions because they are complex instructions.
Yeah, internally there is a risk.
Yes, internally there is a risk, but they are trying to behave like a CISC. Mm-hmm. And the idea is that I think that Intel was getting the instructions by the dozens in order to try to create a general purpose processor that is going to be able to do anything.
Correct. That's another reason, which is by far the largest reason why we have thousands of instructions.
Yes, because they were trying to fix everything in the silicon. And they were trying to create audio decoding, video decoding, security, everything that you can possibly think of in silicon.
Yeah, and that's the reason.
And these guys, first, they didn't know that they were creating a risk. Mm-hmm. They were trying to fill in the gaps. Mm-hmm. If you take a look at the newer generations or newer derivatives of 602, you will see that a lot of things that got built into the processor, so the new instructions and everything else, is basically just things that were actually needed. So bit shifting, being able to directly read or write the bits, being able to do the branching directly on some bits. So they didn't try to implement instructions
for everything.
They were trying to iron out the corners that were missing because somebody actually wanted to do something in 602 and was missing instructions to be able to do it quickly.
Basically, the summarized answer to the question is because Intel and other CPU manufacturers made such an enormous amount of registers over the course of development of their CPUs for accelerating X, Y, Z, and many other things, and with that came a lot of instructional complexity.
Yes, because even when they were completely changing the way 602 was working. So there's a part called 6565 C816S. So it's the chip that is actually was designed as a newer version of the 602. Mm-hmm. It is a 16-bit chip with 16-bit registers, and it is able to run to use 24 bits of memory addresses.
Okay.
So even when they did that, the number of instructions went from 56 to 92. So it wasn't such a big leap.
Yeah, because in registers in Intel, you're talking about hundreds and hundreds and hundreds of additions per register.
Yes. So what they did is they completely turned the architecture upside down because they introduced basically double the amount of space or double the amount of storage space in the registers in themselves. But they didn't change the processor so much. So this was another way of thinking. And I think this is the reason why people still like older chips. Because they are able to...
Much more efficient.
Much more efficient and much easier to understand.
Yes.
If you see... okay. When I was younger, I never understood how a person could be reading the hexadecimal dump of a program, any program, and to be able to understand anything.
Okay.
When you try to work with 602 for a year or two, you're able to do this.
Yeah, I know.
Because
More than a few people told me that.
Yes, because the number of instructions is so small that it takes you probably a week or two to remember them all.
And learning from the hex dump basically in a year or two is like learning basics of another language.
Okay. So having coughed a little bit, learning assembly is complicated. If you need to learn assembly in Intel, I think arguably it's more complicated than learning C.
I agree.
Because the number of keywords in C or C++ is much, much, much smaller than the number of possible instructions.
Okay.
So when you want to do something in Intel, you need to first think in assembly. Then you need to find out, is there an instruction that is able to do this quickly?
Okay.
Then you need, when you see the family of instructions that does it quickly, you need to learn which one is better, and then you use it.
Okay.
And this makes programming in Intel more or less on par with programming in any programming language.
Okay.
I would say that when you're including all the different libraries for, I don't know, Python or C++ or whatever, it's more like the programming in assembly is something like this. 6502 enables you to go to the basics, to need to think in modules, you need to think in smaller chunks, and you need to think about basic elemental functions. And this is what I like. I like to tell the students that for me, 6502 is a Sudoku in assembly language.
Okay, I get it. Yeah, I agree.
Because it's like chess. The rules are simple, but implementing them is complicated.
Okay. Well, with that being said, there are other reasons why we chose the path of 6502 and then ARM. It's not necessarily something that can be like binary traced or something, but a lot of people do consider the ARM CPUs that were basically created by the parts of the same team that created the 6502. They consider ARM to be what they call the spiritual descendant of the 6502. And I recently, actually, I read some kind of an interview with one of the authors of the ARM CPU, which was like a second version of 6502 made for a specific computer a little bit later, Acorn or whatever it was called. And in that interview, the one of the engineers that worked on that specific those specific projects kind of like dissed on the idea of 6502 being good at all for anything, and or 6502 being in any way related to future ARM processors. That being said, when you look into the reference of instructions for ARM and for 6502, and for example, you check the documentation part about the status flags or stuff like that, ARMs and 6502s basically have the same status flags, and they are basically named the same, and they have the same nomenclature in terms of the names.
Yes, because the nomenclature, for example, for the interrupts, RQ, is directly from 6502.
Yeah.
It's basically the way they name the flags. And as I said, they were inventing things as they moved along. There wasn't a specification that said you need to name the interrupt lines like this. They were using the interrupt, so int or RQ or whatever, interrupt request or interrupt anyway, it was working. And this is probably the reason why people still remember the 602. And the other thing is that once you learn anything else, any other assembly language, when you come to 602, you come to something that looks familiar to you. And you can use it probably in under half an hour. Because if you know how to think in assembly, it's simple to use it. It's just easy. You know different commands. There is not so many of them. It takes you 10 or 15 minutes to understand what is the general idea of the commands that you have at your disposal. And then it's just a question of having some experience with the processor itself, and then that's it.
Okay.
Because I like to think about 682 as being an extremely stupid processor that is completely and utterly easy to talk to, so that it doesn't invent things. You don't need to think about how it is going to interpret things, because it's not interpreting anything. it does exactly what you want it to do. So being stupid in this particular case means not inventing things, something that ChatGPT is extremely good at.
Can I ask you a question?
Yes?
So you are Yasmin and you talk to chips.
Yes. It's easier that way.
That's going to become your introductory sentence.
No. I'm going to introduce myself as playing Sudoku on 602.
Oh, that's so awesome.
Because sometimes it makes sense to, instead of playing Sudoku, try to optimize a loop.
Okay.
Or do something, because you can easily create a loop. You can easily calculate how many cycles does it take to run. You can easily try to invent another way of doing it. You can easily see how many cycles did you waste this time and how to optimize the second one, the third one, and so on. And then to have some way of trying to understand the difference between the different implementations that you did. And this is probably the reason why I like teaching it. Because when I give the students a task, for example, we are using a simulator called Easy602. It's available on the internet. And it has a small part of memory reserved as a video memory. So you can actually write to it, and then it outputs the pixels on the screen. I give the students a simple task to animate a pixel that is going to move around. It is interesting to see, out of 200 students or so, that you are inevitably going to see at least 15 to 20 different solutions that are going to be different and different from everything else that you have seen up to this point, because everybody is going to invent their own different way of solving the problem. And the problem is the same. So I like to see how people think.
Okay, I have something to add to that, which is a little bit of a, let's say, side note. I recently had a discussion about some of the programming books with our students on that same course about art of computer programming, etc. I told you about this. There's a related story to this. I remember distinctly this from high school when I was reading the Knut books. There's a portion of the code which he posted which we typed in the book, and he offered something like, I don't know, $100 per every bug that was found over the years for that specific piece of code.
Okay.
Still to this very day, as far as I'm aware, people are still finding bugs for that specific, let's say, block of 20 lines of code or so, which only actually this kind of like goes along with something that you mentioned, different ways of solving the same problem, which is what programmers do. But also one larger point, which a lot of our students are not aware of, which is there is no correct way to program things a lot of the times. And there are different solutions to the same problem, all of them more or less delivering the same results, or even the same results. But what can be distinctive about them is not the amount of errors or whatever you find in them. It's about how much time and how much resources they take.
Yes, and the other thing is that there are no correct solutions, but there are incorrect solutions.
There are.
So whatever sticks is usually the way that people are programming. And I don't care if it sticks. So I like to see how people think. I like to see different ways of implementing things in assembly. And I like to see how they are implemented in the way that it behaves. So if it fulfills the whatever requirements,
the letter of the requirement.
The letter of the requirement, I don't care. But at the same time, I like to see how people are going around the problems that I posed or dilemmas that I posed them when I was making up the requirements. And I'd like to see how people behave when they try to inevitably Google it, try to find a solution, then suddenly don't see a solution. Because the 6502 has one thing going for it. There is a lot of resources on the internet, but since we are talking about assembly code, usually people don't do the comments well. So if you're looking for a particular piece of code,
that's a good one.
If you're looking for a particular piece of code, either you know what you're looking for, and then you are able to write it yourself, or you are trying to find something that you don't know how it looks like, and there is no pointer to point in the right direction. If I ask you to create, floating point division in 602 code, it is going to be easy because you're going to find code snippets done by Wozniak or somebody else. But if I ask you to create a simple thing like, I want a diagonal line in this part of the memory, this is going to behave like a canvas, and then I need a diagonal line here, there is no code reference because every task is so simple that you cannot Google it.
You could give an example, like like turn on the lights in this, like in circular direction or
Yes.
something like that. And
Yes.
it would be completely pointless. There is no way that somebody made that already.
And Fixit 6502 has additional thing with going on with ChatGPT, because ChatGPT has seen an enormous amount of examples in different assembly languages, and since most of them are similar to what 6502 assembly language looks like,
It assumes that it knows.
and no, it makes up and mixes up the instructions. So
That's so bad.
Yes, it starts using instructions from another assembly language and then switches back to 602, and it is hilarious to look at. No, no, I have a few examples for the instructions that are completely made up by ChatGPT, because it doesn't. It isn't. ChatGPT still isn't able to compile those things, so he doesn't understand that this is not going to compile, and it looks okay for him.
Try to make it.
Yes.
Write some kind of a code about some program, whatever, which uses some kind of a accelerated AVX 512 register instruction or something. Try to do it on purpose. But ask it, I want you to make me a program in 6502, which uses the AVX 512 instruction on purpose. Not now, but try to do it for fun and games. Okay, so now we have to discuss some other things related to 6502. Now I'm going to turn completely, unaware. I don't know what the hell we're talking about. I don't know anything about 6502. Why is that? So forget about history now. We're talking today. Why is it important?
Two things. First, in order to understand the assembly language that we are using today, and to understand the computer architecture that we're using today, you need to understand how 602 was created, because I think that it is the right link. It's not the only link, but the right link between the Turing machine and von Neumann's architecture and what we have today. It is one of the more links that we have, but I think this is the right one, because it has enough of the history inside it, but it is complex enough to be able to behave like something that can be programmed today. Because programming Turing machine is simple.
No, it's not.
It's simple, but it's tedious.
No. It's simple in terms of the simplicity of operations.
Yes, but it's tedious.
It's very difficult from our perspective of people who think on much higher level.
Yes, so we need a link. We need something that is higher than the Turing machine, but is lower than the normal C. And I think that 6502 fills this link in order to be normal enough, because I consider today's processor to be too complex for this.
Okay.
You cannot explain a single pipeline thing with a processor that is able to run on 24 cores. So you need something that is simpler than this, because people don't like to see a complex thing. They want to learn on something that's simple.
Surely don't want to start with it.
Yes. So we need somewhere to start.
So induction methodology, basically.
Yes.
Okay.
Basically, if I use something simpler than this, it wouldn't be as effective.
But that's the computer science explanation. Is
Yes.
there another explanation? I'm not shooting for an answer. I don't know. I'm just asking.
I think that the biggest thing is that everybody's using it because they know how it behaves.
Where?
Everywhere. If you are using industry automation, you want to be able to formally verify your code. It is simple enough to be formally verified. You can understand how it is going to behave. All the bugs are known. All the unknowns are known right now because it has been used for the last 40 years. So you can be
Almost 50.
You can be reasonably sure that whatever you do is going to be completely understandable to everybody, including the risk assessment guys, so that you can actually write critical code in it.
Okay. Yeah. Are there any other parts of the industry where this is used?
Other than education industry as such, and
I don't know. Sensors, IoT, something.
Yes, but when it comes to sensors in IoT, it is hard to understand what is happening because 602 is so ubiquitous and so small that you can basically put it inside a chip that is going to have the 64 Ks of memory. It's a small chip. 64 Ks of memory is small. Your chip is small itself, so you can probably create a controller that is going to fit into the USB cable. And you don't know it's there, because since there are no reasons for people to explain this to you, I can put it in a USB cable and not tell anybody. So I'm not sure. I don't know what is actually containing the 602 today, because it is so ubiquitous that people can basically make 1 million of those, put them inside the camera, put it inside the cable. For example, you have a cable that is showing you the level, the energy level or whatever. Maybe it's powered by 602. I don't know.
Yeah, that's actually imaginable. That's a good example.
I don't know which microprocessor is there, but something has to drive the display, and something has to understand the sensor that is going to be measuring the power. So it could be 602. It can be something similar to it.
We're going to disassemble one of those cables and check
even
for fun.
Even if you disassemble it, it can be a small chip with only a couple of pins on it, because since the memory can be inside the chip, and this can be made extremely small, you don't need anything else than the connection to the sensors.
Okay.
So it's a simple thing to implement.
Okay. And now, kind of like slowly but surely wrapping this up, I have another question for you. You mentioned something about those old computers, etc. You said you were a Spectrum guy.
Yes.
Which is Z80.
Yes.
Why are you not a 6502 guy? And don't tell me it's generational, because it's not.
I think that the main reason is because I was used to the games on Spectrum look better than on 6502 if you don't have the additional chips, because Z80 was easier to work with. So this is something that we can safely say that out of the box, Spectrum looked better than everything that can be done on 602 only processor.
You mean like Commodore 64 without the turbo modules and stuff like that?
Yes,
something?
but Commodore 64 without the modules is not Commodore 64.
I agree.
Because I was raised on Ora. Ora was a school computer
here in our region.
Here in our region, and this computer was basically 602 with almost nothing at all except the memory, and it was rudimentary. So I preferred Z80.
Okay, that's okay. I used Atari a lot. I saw what it was able to do. Even those older versions, which were 6502 based, it had a very good GUI for its age back in the day, which was beginning of the 90s or something, end of the 80s. So yeah, for me, it's the other way around. Okay, but basically, I never had a Spectrum. Actually, I bought one of those. Yes. This is recent because I want to play with it. I played Spectrum exactly once in my life with one of my cousins. That's it. 664, I played all the way to high school, and I had Amstrad when I was much younger, of course.
It's a thing that is basically a chance. I got my Spectrum back when computers weren't as available as they are today, and today, if you don't like your console, you buy another one. So basically, it's easy to switch from PlayStation to Xbox, because you play PlayStation, you like PlayStation, then you say, okay, in the next generation, I'm going to switch over to Xbox and just buy another console.
If I can be a little bit stupid, I think that the only way in which people are going to do that is going to be in the other direction, but that's just me.
Okay. Anyways, but back way then, the computers were too expensive to buy another one. So you couldn't switch from Spectrum to Commodore 64 because nobody was able to normally afford having two different platforms with two different sets of tapes with everything else that needed to be done.
Yeah, and it's completely different in terms of how you were using them. And Amstrad was also different, and Atari was also different.
Yes, and the media was different. For Commodore, you could buy floppies. For Spectrum, you were stuck with tapes. Then with QL, you had microdrive, which was completely proprietary and basically useless. So basically when you bought a platform, you were stuck with it.
I agree. I remember the first PC that I got way later, actually. It was crazy expensive. The XT generation, 8088.
But no, PCs or as they were called, enterprise level or business computers were expensive as expensive they can get. Even there was even an Amstrad PC.
There was at the end of their journey.
CPC, yes, I have one of those at home. It was a CPC that was
Atari had a handheld device as well, the Portofino Portfolio, something like that. I had it.
Yes, I had it also.
With the external printer or whatever it was.
It was basically emulating IBM XT.
Mm-hmm.
And it had DOS.
Yes, I remember.
Yes, it was amazing small piece of nothing that you could take with you.
We have to do an episode about those old devices. I think we already had a discussion about this. I have some to contribute, and when you go to your attic, you're probably going to find history museum there for that.
Yes.
Okay.
I think we are done for this episode. Let's call it a day, and let's just say that in the background, I did the thing that you asked me to.
Okay.
I was asking I was asking for the code on the ChatGPT. And as I said, he's making up instructions. I'll show it to you later, and we'll put it in the description or somewhere. But it has made its own set of instructions for the 602.
Oh, it's really good when you have such an inventive tool.
Yes.
Especially when it has no relationship to reality.
Yes.
Okay.
Anyways, thank you for listening to and watching us.
Yeah. See you next time. Bye.
See you. Bye.